Okay, so last part of the day, and yeah, happy to see, well, you all made it in one piece. And well, this is going to be super interesting. I'm really happy that Ruben Verborgh is here today with us. He's, well, one of those people who wear many hats. He's a researcher at Ghent University and also affiliate researcher at MIT and also technology advocate for Inrupt. And I guess this last bit may be the most relevant today in a way because he's going to be talking about decentralization, solid, linked data, and how all that stuff somehow comes together. So, on to you.
Big data, we all know it, and I generally dislike it because I think it's killing innovation. The good news is that connected data can help us bring back that innovation that we're missing. Today, I'll talk about solid, and solid is a way of redefining the relationship between people, companies, services, and data. What we're going to do is move data closer to people, because that's good for many reasons, not just for privacy and control, but also for innovation, for doing meaningful things with data. So let's have a look at how this works. I'll be talking about three things today. I'll start with this redefining of that relationship between apps, data, and people. And then I'll go to the solid ecosystem, explaining what the parts are, how it works, how you can use it. And then finally, I'll zoom in on the technical side, like how it is that this connected data exactly helps with realizing this vision. So first, let's talk a bit about this relation. Now, all of the examples that I'll be giving will be in the context of social media. However, I'm not selling you a social media platform. It is just one example that we all know because we all use it or we all know someone who uses it. But as I give the examples about social media, try to transform them into completely different kind of domains because this is a data story in general. This is a picture that you might be familiar with. They are the walled gardens that we have in social media, but if we're honest, we have those walled gardens everywhere where there is a vendor lock-in, which is, as you know, in quite a lot of places. What is the essence of the walled gardens? Well, it means that there's barriers in between. The idea behind the open web is that we can just interact with anyone we want, with any piece of information we want. However, the walled gardens are the result of a way of innovation that goes against this spirit. Within the walled gardens, you cannot easily share information among different systems. Simply said, you cannot share your Facebook photos with your LinkedIn colleagues. I mean, you can, but you have to either move the data or to move the people. So either you have lots of copies of your data or you have people that are people on multiple networks and so on. So it gets really complicated. And if you really think about it, this doesn't make sense. Just to give you one example, have you ever tried changing your profile picture? If you do that, you have to change it in every single place that you want to use. And sometimes years later, you still find your old profile picture. This is a result of data being close to the application and not being close to the person. So this is what we want to change. Now, Solid is not a platform. Solid is not saying like we should all do this differently. I mean, it kind of is, but it is foremost about giving choice. I'm not telling people that they need more control or more privacy or more innovation. I'm telling that if you want, you should have the choice to do so. The Solid ecosystem is about enabling people to use the apps that they want to use while still storing the data wherever they want to store it. And this is not true today, because yes, you can pick your applications that you want, but they can only interact with those people who are using the same applications. If they're not, well, then you're out of luck. So we're going to decouple this. We're going to put data separately from applications so people can freely choose the apps they want. And we want that people can control their data and then share it with the apps and people they choose. Sounds very simple, and it is conceptually, but it is a concept with really strong consequences. The main concept behind Solid is something we call a data pod. It has different names like data vault and so on. The idea being is that every single one of us, you get your own space, your own place where you can store your data. That's it. So you're not storing it with LinkedIn or Facebook or any other app. You're storing it in your place, conceptually. This is where it starts from. Very simple idea with huge consequences. For instance, this is a view that you're very familiar with today, right? And a view like this one consists of thousands of pieces of data, and today, all of those pieces, they will come from a single place. If it's social media, they will come from Facebook, let's say, right? However, if every one of us gets their own data part, then this view suddenly needs to get data from different places. For instance, if this is my social media post, well, then this profile picture is going to be stored in my data pod. The text is going to be stored in my data pod. If you comment on my post, the comment is yours, it's going to be stored in your data pod. And even a piece of data as small as a like. If you like my post, if you like a comment, this like is yours, is going to be stored in your data pod. And then it gets really crazy because that view can be built up of pieces of data that are coming from hundreds or thousands of different data pods. So we're no longer talking about big data here, we're talking about a huge number of very small data sets, and they are connected. So a totally different way of thinking. What kind of consequences does this have? Well, on the left-hand side, you have today's landscape. And today, data and apps are tightly coupled with each other. They're inseparable. So on Facebook, I have my contact list, I have my pictures, I have my agenda. LinkedIn has contacts, and Doodle has my agenda as well. There's no synchronization. So if I accept an event on Facebook, then Doodle won't know about it. If I have a new colleague, then Facebook won't know about it. Well, maybe that's a good thing, but the thing is, even if we would want, we still can't do that. And this means that we have this constant duplication as well. Like we always have to keep things in sync because the data resides with the applications. And this is what creates those data silos. And again, it's not just social media. It's basically every app that we use will try to hold on to our data because that's just how they work. On the right-hand side, you see the consequence of what happens when indeed we all store our own data in our data vaults. And those rectangles that you see, they're the same apps, except the data has been pushed out. So the data is now in my personal data vault. And this means that I can start with one application, work on data, and when I'm done, I can continue with the next. And there's no need for synchronization because my data is only in one place, in my place. And this makes a lot of sense because why would we want to maintain all those copies? I mean, this, if you think about it, is how it should have been all along had we been ready technically. It also means that we can make different choices. The left-hand side, if we want to interact, we need to use the same apps, the same systems. On the right-hand side, I can use one app, you can use another app, and it still works. Because the integration happens not through the application, but it goes through the data pods. And this is where it gets really interesting, because the left-hand side is a world in which there's only one app. The app is built for the average user, like the Facebook app, for instance. It's built for the average user, which doesn't exist. On the right-hand side, because you have a choice of apps, you can have more specific apps, like everyone can use their own thing, basically, and they still collaborate together. So this is a very fundamental change. This, of course, is great for people, because people get choice. And you don't have that choice today. However, it is also great for companies and for innovation. Let me explain that a bit more. Right now, again, the left-hand side is today. This is what we have. We have a single market for centralized apps. So you get this competition that's not based on quality of service, but data ownership. The competition there is who has the most data, which is great if you're one of those having most data. However, it kills innovation. Let me give you two examples. On the one hand, think about Facebook, right? Facebook is a major company. How well do they innovate? Well, let me ask you. Who can name me one innovation to your personal newsfeed in the past 10 years, which is an eternity in technology, and that Facebook has done for you? You might not know this, but they have done one major innovation. Instead of just doing likes, you have now 5 different emotions. But that's about it. Facebook doesn't innovate. They don't have to because they're in the data collection business. That's the kind of game that they're playing. Fair enough. However, kills innovation. Even worse, second example. Suppose that someone has a revolutionary idea. They have a new idea on how to Present information for social feeds. Totally new concept. Too bad. They cannot enter the market because they don't have the data. So not only do the big companies not innovate on that front, those who want to innovate can't because they depend on data for doing so. On the right-hand side, we get a new world that we would have if people keep data closer to themselves. Because then you get a competition on two levels. On the one hand, there will be competition between those offering data as a service, places that give you data vaults where you can store your own data. On the other hand, you get a separate competition between apps. And this is where it gets interesting, because again, the left-hand side is where you have the one app for the average user. This means that grandmothers and grandchildren are literally using the same app. Because it gives the best experience? No, because the data isn't there. The right-hand side is a market where grandmother and grandchild have their own apps, but can still interact because data has been decoupled from the app. The left-hand side is competition, where there's one winner. The right-hand side is two competitions, but many more winners, because everyone can pick the deals that are best for them, and the deals picked for data and for apps are different. So this is where the innovation will happen. This was a concept on how things work, so the separation between apps and data. Now let's have a look on how this concretely translates into technology. I'll talk about the Solid ecosystem. So Solid is not a company, not a platform. It is foremost a set of standards that make this work together. If you compare Solid to anything, compare it to the web. The web is also an open platform with standards, and you can choose your browser. You can choose whatever software you use to make websites, and they all work together. You can view a website on mobile, on desktop, on laptops, and so on and so forth, and they still work. So this is what we're talking about, and this is not a coincidence. Solid is started by Tim Berners-Lee, who invented the World Wide Web. And basically, what he wants to do is bring back the original principles, bring back this openness, this permissionless innovation, where we don't depend on companies harvesting as much data, because that kills innovation. Solid is more than just software. It's an ecosystem, it's a movement, it's a community. It's an ecosystem in the sense that it's based on standards, so this is the key thing. They're contracts that anyone can implement. It's a movement in the sense that we want to build apps in different ways. I'll talk more about that later because it's a really different approach to building apps. And it's also a community in the sense that there's different people with different backgrounds, different companies, different organizations who want to contribute to Solid. And the important thing is that anyone can build or host software for Solid because it's not a platform. If you implement the standards, well, then you can participate. For instance, you can have your own server at home or in your workplace. You don't have to connect to anything else. You can rent server space, or you can use one of the free servers. Basically, having a Solid data pod is like having a website. You can self-host, someone else can host, you can host with a small or a large company. It is your choice. So I'm not telling people you should have your own server. I'm telling people you need choice. If you want your own server, you can. If you don't want, that's fine. I don't care. What is a Solid server? Well, a Solid server acts as a data pod, and it will store and guard your data. It is by all means a regular web server, so we're using the existing web stack. We add just a couple of layers on top. There's access control and there's linked data. The server itself is application agnostic, which is really important. It means that you can build any application and that all application-specific logic resides in clients. It is like a website again. Just like a website can be opened with any browser, a Solid pod can be viewed with any app. What's in a data pod? Well, like a website, you name it. Profile, pictures, comments, likes, whatever. Whatever you want to put in it, you can put in it. It is a website. Your imagination is your only limit, basically. What are clients? Well, clients are browser apps or native apps that read from or write data to your pod. And you give apps permission, and you can be very specific about what they get to access. You can say, this document you can see, this document you cannot see. You can give friends permission, friends can give you permission, and so on. The things you already know, but this time you control whatever happens. And it's up to apps to deliver a unified experience. So the views that we saw in the beginning, apps, if you use an app, you should notice a difference whether it's Solid or not, except that when you see an app, in reality, data will come from many different places instead of coming from one single backend. What kind of apps can you build? Again, it's the same like the web. If you can envision it, you can build it. It's not a totally different platform you're just building on top of the web. The web is a platform. However, the difference is that if you start building, you don't need data. Because right now, if you're a startup, the first worry you have is, how are we going to get people's data? Because without data, you can't build apps. Here, you don't have to worry. People come with their data. They will give you permission to see specific parts, and then you can start showing it and interacting with them and so on. So it's all based on features. It's not based on data harvesting. Now, this is nice in theory, but does it work in practice? Yes, it does. However, it's not made for end users yet. So this is in the prototyping stage and development stage. We're trying out technology to see how it works. So you can use it if you're brave, but it's very rough around the edges. That said, there's several implementations of solid servers. You can store your data already in a data pod. My data is stored in one. There's some free storage available, or you can deploy your own as you wish. App-wise, there's a couple of them. There's data browsers, there's contacts apps, photos apps, and so on. And if you don't find what you want, you can build it yourself, because that's a good thing. Again, you don't need data to build something. There's also several libraries that help you build your own solid apps. So you can try it out if you want, but warning, very rough around the edges though. Now, how come? Well, Solid started as a research project at MIT. And there we have designed the initial protocols, the initial standards, and so on, and the prototypes as well. And those are what we have today. However, in computer science research, the problem is once you've solved the technical challenges, you have to move on to the next challenges. But that way you don't get it to the end user. So Tim Berners-Lee is currently behind a startup called Interrupt. And what he wants to do really is to show the world that you can have a healthy company based on data without doing data harvesting. So he's trying to lead by example, showing that it's possible to do nice things on the web without doing data harvesting. And Interrupt is contributing to the open source ecosystem with implementations, helping with the standards and so on. And they will also have a couple of products down the line. However, it's very important that Solid and Interrupt are very different things. Interrupt is trying to be one company in a bigger ecosystem. Or let's say it differently, if Interrupt is the only company, then they have lost, because Solid is all about competition. So what we're trying to do is open up the market to different players, because the more people start doing this, the more beneficial it is for everyone, really. So think as Interrupt as one of the players that is trying to open up the ecosystem for everyone. So I've talked about this new way of thinking about data and people. I've shown you what the ecosystem looks like. Now let's have a closer look at the deeper layers, like how does it work on a low level? Because there must be some magic technologies behind this. Of course, there's never magic, but there's a couple of interesting things to be done there. Because the main difference is that decentralized apps, they will have many backends. And those backends need to work with many apps. On the left-hand side, you have today's situation again, where one backend, one app. You know how it works. And this is really easy because you know exactly what the contract is. And if you don't like the contract, you can change it, because often the backend and front-end teams, they work closely together. So this is about as easy as it gets. However, on the right-hand side, we have the world that we're preparing for, which is one where data pods interact with different apps, apps interact with different data pods, and one app has to read data that has been written by another app, and we have to have this handoff. So what we get is a really complex way of interaction, basically, because you cannot predict anymore what the data pod will look like. And this means that we have to completely change the way that we think about building apps. Because this is what it looks like right now. You have application-specific logic that go to specific server interface, and you hard-code the interactions. So every client has HTTP interactions hard-coded that go to a specific server. Which means that if you have servers that do kind of the same thing but not quite, they don't work. They are incompatible. But this does not work for two reasons. First of all, you cannot make assumptions about what the server looks like, because everyone can do their own thing. And second, you don't even know to which server you'll need to go, because data can be distributed across 1, 10, 100, 1,000 different servers. So you cannot hard code, because you simply don't know where data will be at runtime. So we have to evolve towards a different way of building apps. And the way that I think about it is a query-based contract. So instead of in your application-specific logic hard coding what you want, you express in a query like, this is the shape of the data that I'm looking for. That's all you do. And the interesting thing is that such a query captures what you want without being specific to a certain backend or a certain network. This also means that you need a query with universal semantics. So your query will need to have a meaning that is the same across all data vaults in the entire world. So things like GraphQL won't work because one GraphQL query has different meanings depending on who you're asking. So we're really thinking about this global space where a query has meaning and the same meaning for everyone. So this is how you build apps, only using queries. You don't use HTTP requests because those will be different every time. And then it's up to a query engine on the client side to translate those requests, those queries into concrete requests to interfaces on different data paths. Now, there's one problem with this picture, and that is it depends on a really strong query engine that will do all the magic at runtime, of course. But the good news is this engine is reusable across different applications, because this is all about making sure that the application-specific code does not have to change. The contract we build against our queries, and if interfaces change, that's all fine, because it's only the translation step that has to change. The application itself does not need to adapt. Now, of course, this comes with huge interoperability challenges, and we solve them with linked data in RDF. First challenge is, if we all store our own data, how do we connect it to other people's data? And how can apps share data without having to first agree on everything? And finally, how do we integrate data from multiple data paths? Well, the answer to all of these things, for me, is RDF. The first question, how do we connect it? Well, using links. For instance, this is me liking Connected Data London 2019. And guess what? There was no like button on the website, but I liked it anyway. And this is what I can do if I'm in control of my data. I just made a link to Connected Data London, and I liked it. That's it. This is my like. So this is how it works, connecting two things on the web. How do applications interoperate? This is a complex topic that needs more than just 2 minutes to explain, but the bottom line is this: we're basing it on shapes. So instead of training applications to know exactly what to expect, we train them on specific shapes. So applications know how to recognize a like, but they can also ignore all the things that they don't understand. So it's based on shape matching, the query engine thing. And finally, how do we integrate data from many different sources? Well, this is the easy one. Because it's RDF, you can just merge the graphs. And this is the reason why I'm insisting on this universal semantics, because we'll need to combine data from random places in the world and they need to work together. So this means that you need a consistent semantics, a consistent meaning across all those possible data paths. This also means that we'll need to do something for developers, because this completely changes the way that they're used to developing things. So I think this is the most crucial success factor that we'll need. Front-end developers are the ones that build the apps that people see. And together with UX designers, they're the ones bringing Solid to people. We should not make the mistake as Solid or as Interrupt to say, look, we're going to bring it all the way to the end user. What we should be doing is thinking in terms of enabling others. So we want to enable developers to build things on top of Solid. So rather than doing it ourselves, we think about how do we make it better for them. And the interesting thing is that if we help developers build better apps, we also help ourselves doing it. And this is something I noticed, and I'll explain it a bit later. And this, to me, is a crucial part, because you'll hear lots of things about RDF being complex, and a very convincing argument, in fact, was made this morning. However, Dan Brickley and Libby Miller had a beautiful quote saying that people think RDF is a pain because it is complicated, but the truth is even worse. RDF is basically simplistic, but it allows you to work with real-world data and problems that are horribly complicated. And this is a horribly complicated problem because data is spread all over the world. How can you fix this? By giving people tools. For instance, I myself have been working with simple React-based tools that give developer access to this whole world. So this is just a component way of building apps, and it doesn't look too special, does it? This looks quite regular. However, let's have a close look at these things. They're micro-expressions, they're queries. And those are queries, not just to one data source, but they're queries for the full web. I call this the LD Flex language for linked data and flexible querying. And it works like this. So you can do things like data.user.name, data.user.friends, and so on and so forth. But this one is interesting because the first name of those friends or their profile picture is not coming from the user's data space, it's coming from their data spaces. So this is a forward federated query going out to the web. And I can do things like their friends' first names and even just have a random URL in there. And for instance, this one will lead you to my blog. So these are expressions that go to the entire web instead of just one local data source. And how this works on the low level, it's just regular JavaScript, but it feels like a local object. It's actually a proxy that will go to the whole web and get data from there. So if you await it, if you go into asynchronous mode, it will start fetching things, and you as developer don't even have to care where it comes from. So that's the level of abstraction that we're talking about. So today I've talked to you about the new relation between apps, data, and people. I've explained how the ecosystem can work, and also what the underlying technologies are that connect all of this together. However, as a researcher, I have an important statement to make. And that is that in my semantic web community, we often think that problems are solved. Like we focus on the hard research problems, like federated querying, and then we assume that all the rest will be solved by the engineers. But the state of the art in the semantic web community for federated querying is, let's take 10 servers, put them in a basement, connect them over Ethernet, and then we do federated query. However, if you take that to the public web with 100 sources on unreliable connections with different data models, our nice theories don't change. So the 80% that we think that we're solving of the problem is actually quite small. Bring all of those theories into practice requires a lot of research and a lot of engineering to make it work at the scale of the web. Thank you.
Great, thank you, Ruben. So I'm sure there's tons of questions. So.
Can you hear me? Yeah. So I would be wondering, what sort of applications do you think shouldn't be written in this way?
All applications. No, so my honest answer is like, for most of those applications working with personal data, because with personal data we have major problems. It is expensive right now. You have GDPR, you have social pressure not to do it, and also business factors. But there's a couple of application scenarios that are very interesting for this, in particular e-government. Governments are really asking for things like that, especially in Europe where it gets so complex. E-health is also a very prominent example because different hospitals have records and so on. So if you can just put them with the patient, that makes sense. So expect those niches to be very prominent examples.
But which won't be good examples, for instance? What sort of application would you not do this for?
I think examples where there's no real personal data involved, I would say. So more point-to-point things and so on might be less interesting, but I would need to think of concrete examples.
How difficult do you think it is to achieve universal agreement on semantics? And to what extent is that going to inhibit innovation, that people just can't agree on what something means?
Extremely difficult to the extent of being impossible. However, the good thing is we don't need full agreement. We can use smaller decentralized agreements. There's a very small set of concepts that will all need to agree on, but the more niche you get, the smaller the set of people is who actually need to agree. And the good thing is, because we have the RDF model, it is also possible, if different initiatives start, to align them after the fact. So the whole complexity of the RDF stack is justified because exactly we don't want this central agreement, because this is so slow. So we need to rely on decentralized agreement.
Hey, this is more of a kind of a political question, but how far do you think, I mean, do you have a vision of bringing this technology to make the world of the Google and the Facebook change, or you started with the idea, no, this is impossible and we have to create, you know, a parallel track because there's no way that these people are going to get it?
We have to do it all at the same time. However, be aware that it might seem like we're the enemy of the big companies, but know that even the big companies are struggling. Take Facebook, they're the biggest, but even Facebook is desperate on how to acquire more data. So I'm quite sure that they know that their model today is finite and they're desperately looking for alternatives. Take another example, Google. They have lost the social media market. Now, wouldn't Google like to be a provider of data vaults in this ecosystem where they can then maybe attack the monopoly of Facebook. So even for big companies, it makes sense to think about these things.
I mean, that's very important.
So Solid is very attractive from the point of view of users controlling their data, but often there are good performance-related reasons to centralize data. How do you speak to those concerns?
Yeah, so first of all, very good point. Because if I explain this, some people sometimes say, oh, this is nice, now you have new research to work on. But actually, setting the rules in this way is so meaningful that we believe it justifies looking for new solutions. So indeed, we will have to look at those things just because the rules are meaningful. However, decentralization does not mean that there can be no centralization for performance optimization. So of course, to make this scale, we will need caching, we will need indexing, and so on. The difference being that the source of truth is with the individual data vault. So if the caches blow up, you can still find the answer, it is just going to be painfully slow, which is very different from today, because if the central systems blow up, then everything is gone. So yes, we will need massive caching and so on, but there are only optimizations, which is a good thing.
Okay, this is going to be the last one, but don't go away because there's a panel on which is direct continuation of what we're talking about.
Hi, have you done any thinking about what the incentives might be for new app developers to get into this? It's a bit more limiting on the kind of revenue generation models they might have.
Innovation. I'll give you a very short example. A couple of months ago, I had an AI company knocking on my door. They built AI to type people to jobs, which is really great, but there's only a way to make their algorithms better, which is more data. And if they need more data, they're basically competing directly with LinkedIn. So they knocked on my door saying, look, we don't want this. We don't want to harvest data, because the moment we do it, we've lost already. We want such an ecosystem in which we don't depend on data harvesting. So instead of having 50% of our people working on it, we can have 100% of people working on innovation. And the data, we don't want it. Please keep it. So innovation to me is a driver for these things.
Okay, I know we could go on for a while, but we're going to have to wrap up because there's a panel coming up, so don't go away. He's staying, I'm staying, you stay.
Thank you.